Okay, so today we'll be going through the Tech 3 of a 2023 Methods Unit 2 practice exam. So first we have question 1, split up into 2 parts, both worth 1 mark, so working is not necessarily required, but it definitely helps. So first thing we notice with this is it's something to do with one of the reference angles we know, pi on 6. The reason why this is useful is because we've memorized the table for exact values. So I'll quickly write out this table for us. Now, we go 0, 1, 2, 3, 1, all on 2. And they all have a square root on top. And the square root of 1 is clearly 1. And you would just flip these. However, since we're dealing with sine, we already know we just have to deal with this. So from what we know, sine pi on 6 is equal to a half. And since we know that sine 7 pi on 6 is linked with sine pi on 6, we know that sine 7 pi on 6 will be equal to a positive or negative a half. So we have to determine whether it's positive or negative. The way we do this is to check the quadrant. From the eye test, you can clearly see it's in the third quadrant. A way you can check this is if you check the unit circle, pi on 6, pi on 2, pi, and 3 pi on 2. Now we're in pi on 6, so we can just change the fraction to make it easier for ourselves. And 9 pi on 6. Clearly, 7 pi on 6 is in between 6 pi on 6 and 9 pi on 6, 6 and 9. So it's in the third quadrant, meaning it will be negative because if we have a look, SATC, all stations to Camberwell, in the third quadrant, only tan is positive, meaning sine and cos are negative, meaning that sine 7 pi on 6 is equal to negative a half. Next, 64 and negative 2/3. First thing that is annoying me is the negative. Now we know that you can change the sign of the indice and flip it. This is from this indice rule. You just put it on top. Now, the next thing that's annoying me is the fraction. Now, we have an indice law that if we have this, we can turn it into 1 on n. Because m times 1 on n equals m on n, clearly. So we can either split this up into 1 on 64 squared to a third, or 1 on 64 to 1/3 squared. Now, which one seems easier? To me, I would say this, because we know that 64 to a third is equal to 4. It's 4 cubed equals 64. So let's write down our step. Squared, easy. And that's, you can do either. However, clearly one of them is easier, because 64 squared, I doubt anyone will know that off the top of their head. So simplifying 64 to a third, that is equal to 1 on 4 squared. And 4 squared is simple. 1 on 16 is our answer. Cool. Question 2. Simplify log base 7, 7 plus 2 log 7, 149 minus 2 log 7, 7. Now, this is worth 2 marks, so a little bit of working will be necessary. What we can see is they all have base 7, so it's somewhat nice to us. Instead of combining them all at once, we might be able to simply simplify each one individually. So log 7, 7 is equal to 1. This should be a simple log rule. And the only reason we know this is because log base of a to the same number will always be 1. Now, so this part is dealt with. Now, 2 log base 7, 1 on 49. The key with logs is to always get whatever is inside the bracket to something to do with 7. Just from inspection, we can kind of see that 49 is linked with 7 squared, and clearly there's a 7 there. So let's change it. 2 log 7 on 1 on 7 squared. Now we can manipulate this further. It becomes 7 to the negative 2. Now here's a log law we should know. If we have log a b to the m, this is equal to m times log a to the b. And you're simply moving this guy to the front and getting rid of the indices. So let's do the same. This would become 2 times negative 2 times log 7, 7. Simplifies to negative 4 log 7, 7. And from before, we know that anything to the base of the same thing is equal to 1. So this is equal to negative 4 times 1, which is equal to negative 4. So this is this part done. Now let's move on to the last part. Negative 2 log 7, 7. This one's easier for us. We've already been through this. So since log 7, 7 is equal to 1, this would be equal to negative 2 times 1, which is negative 2. And if we plug all these values back into the original equation, we'll end up with 1 plus negative 4 plus minus 2. And that is equal to 1 minus 4 minus 2, which is equal to minus 5. Right. Solve question 3. 3 parts, 2 marks each, meaning a little bit of working is required. Solve the following equation for x. Now, whenever we deal with indices, similar to how we want the bases to be the same, we want the base to be same. So we can have 3 to something disgusting equaling 3 to something also disgusting. But since they are the same base, we can make it easy for ourselves. And this looks like something we're used to. So we're going to use the same principle. We don't mind if the indices are gross, as long as these two are the same. From inspection, that just means you can kind of see. You can see that 5 and 25 have a lot in common. In the fact that 5 squared equals 25. So we're going to use this fact to know that 5 to the 11 minus x is equal to 5 squared, make sure we keep the brackets, to the x plus 1. Now using our indices rules, if we have a to the m to the n, this is equal to a to the m times n. In this case, our m is 2 and our n is x plus 1, meaning m times n would be 2 times x plus 1, which is equal to 2x plus 2. A common mistake would be 2x plus 1. Incorrect. So let's expand 2x plus 2. Now this looks much easier for us to solve. So 5 to the 11n minus x equals 5 to the 2x plus 1, meaning 11 minus x is equal to 2x plus 2. Simple algebra, we'll move the x over first, plus x. We end up with 11 equals 2x plus x plus 2. We'll move that over here. This equals 11 equals 3x plus 2. 9 equals 3x. Therefore, x is equal to 3. I will check my audio quickly just to check that everything is okay. Okay, everything should be okay, hopefully. Now, on to B. Now, onto logs. Now we can see that the bases are the same. It's going to be nice to us. Now, since they're the same and there's nothing in front of each log, we can combine them using our log law, that log with the same base of anything is equal to just, if you can combine together and divide them across. We're going to use the same principle, but this becomes log 3 x plus 8 divided by x is equal to 2. Now, from here, we can simply use another log law. So one I like to use is log 10 100 is equal to 2, and 10 squared equals 100. Notice how the bases shimmy around. This means that 3 squared is equal to x plus 8 on x. So using our algebra, we'll just simplify it out. There we go. Now with logs, we also want to make sure that this exists. So if we sub back x into each log, x plus 8, and now our x is 1, it's positive, and what we're basically checking for is the thing inside a log has to be positive and non-zero. And in this case, we end up with 9 and 1, and 9 and 1 are both positive and non-zero. Now, this one is a slightly trickier one, especially if you are unsure of the rule to follow. The way we want to do this is we want to turn this into a quadratic. What a quadratic is one of these, x squared plus x plus 5 equals 0. The way we're going to do this is we're going to let a equal 2 to the x, and a squared is equal to 2 to the 2x, because 2 to the x times 2 to the x is equal to 2 to the x plus x equals 2 to the 2x. This is a indice law that we should be comfortable with. So let's convert. This turned into a squared. This replaces that. Minus a replaces this. Minus 12 equals 0. Now, this is a factorizing technique we must use now. We need something times something equals negative 12, and that same something plus that same something equals negative 1. Now, since we're multiplying to become negative 12, one of them has to be positive and one of them has to be negative. And since we're adding them together and it becomes a negative, the biggest number has to be negative. So let's list the factors of 12. 1 and 12. Oh, sorry. 12 and 1. 6 and 2. 4 and 3. And we're not going to do these guys because we know that this is going to be negative, meaning the negative number has to be the largest. So these guys, we don't even need to think about them. If we add these together, negative 11, negative 4, negative 1, we have a winner. So that means we have a plus 3, a minus 4 equals 0. That means a is equal to 4 and a is equal to negative 3. Now, what was a originally? A originally was 2 to the x. So that means 2 to the x equals, we'll start with option 1, 4. Now, clearly, you can know x equals equal to 2, or you can do it the slow method, convert bases, x equals 2. Now, let's try option 2. 2 to the x equals negative 3. What you should realize is this is impossible. So that means, that's because an exponential cannot be negative. So that means x is equal to 2 is our answer. Quite a bit of work for 2 marks, hey? Question 4. Consider the function x minus 3 times x plus 2. A is asking us to find dy dx, otherwise known as the derivative. We don't have a formula to, at the moment at least, to get the derivative straight away. So what we're going to have to do is turn it into the form we're used to, and that's going to look something like this. In other words, expanded form. So it's in the name, let's expand. This is equal to x squared plus 2x minus 3x minus 6, x squared minus x minus 6. This looks much better. Now, that means dy dx is equal to 2x minus 1. 1 mark complete. Now, hence, find the equation to the parabola y equals x minus 3, x plus 2 at the point 1 and negative 6. So, find the equation to the parabola. Oh, there is a typo here. It's supposed to be find the equation of the normal to the parabola y equals this at the point 1 and negative 6. So what we want to do is, what are they asking by the normal? Basically, the normal is a perpendicular line to the tangent. And the tangent is a straight line that has the same gradient with the graph. So if we imagine a graph to look like this, if this is the tangent, the normal is perpendicular. So what we want to find is, we want to first find what the gradient of this graph is at 1. How do we find that? We use the derivative. So y is equal to x squared minus x minus 6. dy dx is equal to 2x minus 1. And we found this from the previous question. So at x equals 1, gradient is 2x minus 1, and let's sub x equals 1. 2 minus 1 equals 1. So the gradient of the normal is perpendicular. And that would mean it's a negative reciprocal, but 1 is equal to 1 on 1. So the gradient of the normal is negative 1 on 1, which is equal to just negative 1. So in order to find the equation of the graph, we have y minus the y value equal to the gradient times x minus the x value. So this is from here, this is from here, and this is from here. The answer will be y plus 6 is equal to negative x plus 1, which is y equal to negative x minus 5 is your answer. find the coordinates of P where this normal crosses the parabola. Now, what this graph is asking is, we have the normal. And we're gonna just put normal here, just to remember. We have the graph. And we're gonna use expanded form for now. X squared minus X minus 6. This is also equal to X minus 3, X plus 2. We're gonna call this the parabola. What they're asking is where this normal crosses the parabola. Is basically saying, when does y normal equal y parabola? So that means we take this, and we equal each other. That and this. So we have minus x minus 5 equals x squared minus x minus 6. Let's move everything on this side over. So we end up with 0. X squared minus x plus x minus 6 plus 5. We end up with x squared minus 1. That means x squared equals 1. X squared equals plus minus, x equals plus minus 1. So we already know that they intersect at 1. So now we found out that it intersects at -1. So what they're asking us is to find the coordinates of -1 and this y value. So let's sub that in. We can either sub it into the normal or the parabola. Which one looks easier? I would say the one with less stuff. So y equals -x minus 5. And we want to find out what y is when x equals -1. So this is -1 minus 5. We have y equals 1 minus 5 equals -4, meaning the coordinates of P is -1, -4.
Hey. So unfortunately, my headphones have run out of charge. So this will be a either 2-part or 3-part series, but I will go over this question again. I feel like it has quite a lot to cover, but if you have any other questions, just feel free to comment or ask me, and I'm sure to answer them. Alrighty. Thank you.